All right, we are now on to the first new assignment after exponents, and that's adding and subtracting polynomials. So at this point, you should have a good idea of what an exponent is. That is, an exponent is a count of how many of the base you have, two of them here, or it can be a count of how many times you divide. You divide by 3 twice here, or it can mean things like square root and cube root. So 9 to the 1/2 means the square root of 9, and 27 to the 1/3 means the cube root of 27. So it can mean an awful lot of different things. And then we've also covered the rules of exponents. So if you're counting your exponents, 2 3s and 3 more 3s make 5 3s. So we've been spending all that time to give you a good idea of what an exponent is. And now we're going to start doing operations with multiple exponents. All right, so 19, we're starting with adding and subtracting polynomials. But before I start, I need to define a couple of terms. The rank of a term, well, first let's start with term. This is out of order, but that's okay. A term is one of the parts of an exponential expression. So for example, if the expression was 5x squared plus 2x plus 3, there are 3 terms. Here is term 1, here is term 2, and here is term 3. So that's called a term. It's one of the parts of the expression, and each one of these is separated by a plus or a minus. All right, so I'm going to be talking about the terms in an exponential expression, and then each of those terms has a rank. The total count of variables in a term. So for example, and it's the reason I'm going to be ranking. When I say rank, I mean like, you know, the goes first place, second place, third place. That's a rank. So I can rank, let's say, x to the 7th plus x to the 3rd plus x. If I were to rank these, I would say that this was rank 7 because the count of variables is 7. So I have one term of rank 7, and I have one term of rank 3 because there's 3 x's here, and I have one term of rank 1. And when I'm ranking them, you'll see in a second that I'm going to list them from top rank to lowest rank when I'm adding these exponents. And then, of course, like term, we need to tweak that definition a little bit. Term with the same base and exponents as another term. Okay, so we are used to, let me move some of these around. We're used to like terms just being like you can add apples to apples and oranges to oranges, or you can add x's to x's and y's to y's. But now that we have exponents, we need to be concerned not just about was it an x or a y, the base, but we also have to be concerned that the exponents. So in other words, we're used to being able to add x plus x to make 2 x's, but not x plus y. But now we need to worry about the exponents. So you can add x squared to x squared, but you cannot add x squared to x. Okay? So these have the same base, x, and the same exponent 2 to make 2x squares, but these do not have the same exponents. So you cannot add them together. In other words, this and this are not like terms, and you cannot add them together, just like you cannot add x plus y together. They are different terms. So when we're adding, we're going to rank all of the terms, and then we're going to figure out which terms are like, and then we're going to add them together. You want to pause here in the video if you are following along in your notes to write these down. So the first one of these we're going to do, I'm adding together all of these terms, and only some of them can be added together. But first, the very first thing I need to do is take care of any minuses so that I get all of my minuses right. So I'm going to distribute this negative to these two terms to make sure I've got all the negatives. So this is in fact minus 5x to the 7th, and then negative times a negative becomes a positive 7x to the 2nd power. And I did distributing. So I just distributed the negative, making sure that I get all the terms in the parenthesis. I switch all those signs. All right, and now I'm going to start ranking them. So I've got these terms. I've got x to the 7th, so that's a high rank 7, and then x to the 4th, x to the 2nd. Here's another x to the 7, and here's an x to the 2nd. So here's all the terms. I've got some x to the 7ths, I've got some x to the 4ths, and I've got some x squares. And those are the three types of terms, and I can add the terms that are the same together. So in the x to the 7ths, I've got 7 of them here, 7x to the 7th. I'm going to cross that out because it's taken care of. And then the other x to the 7th is here, 5x to the 7th. Now those are the same. They're like terms, and so I can count them together. 7x to the 7th minus 5x to the 7th is 2x to the 7th. Okay, so the first term taken care of, let's see, I'm going to cross that out because I got it. 5 here, 7x to the 7th here minus 5x to the 7th here give me 2. And now I'm going to keep accounting for all the different terms that I'm adding together. So this is just a way of keeping track of the things that you can add together. So the next term I'm going to take care of are the x to the 4ths, 3x to the 4ths. And do I have any more? No, I don't. So those are all the x to the 4ths. And now the x squares. I've got minus x squared, minus 1x squared, plus 7x squares. So that's, you can put a 1 in front if you absolutely have to. So that's 7x squared minus 1x squared is 6 minus 7. So that's, if I wanted to regroup, I could say negative 1 plus 7, just to make it clear what it is that I'm doing here. Negative 1 and plus 7 makes 6x squares. Okay, so just like if I was doing negative x plus 7x, that would be 6x. Except in this case it's the x squares. Now you cannot add the x to the 7ths or the x to the 4ths or the x squares. Those are not like terms. So I'm done adding together, and my final term is 2x to the 7ths. There's 3 plus 3x to the 4ths, and then the last term is plus 6x squares. Okay, and so there's my final answer. And don't worry, this will start to make a little bit more sense to you as you get more practice. I'm going to pause here, or you should pause here. And then let's move on to the next one. I know this looks scary, but just have to keep track of all the terms of different ranks. So this is a plus. I don't have to worry about distributing. This is a plus. I don't have to worry. So now I'm just ready to start accounting. I've got the highest term is 7. The highest rank is a to the 7. And then the next thing I have is a to the 6. And then there's no 5th, 4th. There's an a squared there. Notice I'm putting these in rank. That is the highest rank, a to the 7th, and then keep track of every term after that. And then I do have an a by itself, and then there's no numbers. Okay, so I've kept track of everything. And now I'm going to add all the a to the 7ths together. So the first one is negative 4 a to the 7th, and plus 7 a to the 7th. So that keeps track of my a to the 7th. There are negative 4 plus 7 is 3a to the 7th altogether. I took care of that one too. Do scribble these out as you go so that you don't have to worry about them, get confused. And then negative 4a to the 6th, negative 4 of these, and that's all of them. 4a to the 6's. And then a squares, there's a 6 here, and a minus 2 here. Those are my squares, my a squares term. And then 6a squared minus 2a squares is 4a to the 2nd power. And then there's only one left, and that's minus 4a. So my final answer is, going from highest rank to lowest rank, 3a to the 7ths minus 4a to the 6's plus 4a squares minus 4a's. Okay, so another strategy for this would be to put a box around the things that you're adding together, but there's so many things to add together. Another this one and this one you could add together. But there's so many things you need to add together that I prefer listing them from lowest rank to highest rank. And if you're following along in your notes, you're going to want to pause here if you're trying to keep up. I'm going to go ahead and move on to the next question. And okay, so what we're doing is we're figuring out which ones of these you can add together because they have the same base and the same exponents. N to the 6, and the other one is n to the 6 here. So the way that I'm organizing the things that I can add together is by listing n to the 6, all of the n to the 6's I'm going to put there. N to the 3rd I'm going to put here. N squared, I do have an n squared, and I also do have an n. So and then from highest rank to lowest rank, I'm going to add the things that I can add together. So I can add this and this. So negative 5 here, plus 5 here, And that takes care of all my n to the 6's terms. Negative and positive, these cancel exactly. 0 n to the 6 or just 0. And so I'm going to leave that off. In other words, these canceled completely. There's no more of those. 5 apples minus 5 apples is no apples. And then n to the third, oops, I almost put that. N to the third is over here. There's 2 of them. And nothing else that I can add. And then the other 2 terms are by themselves as well. Negative 7 n to the seconds and negative 4 n's. All right, so altogether, I'm not going to write the n to the 6's, so they cancel, so I have these terms. So the final answer is 2n to the thirds minus 7n to the seconds minus 4 n's. And pause here if you're taking notes. Next question. So, from highest to lowest, I have an a to the 7th here, I have an a to the 5th, and I have an a. So there is there is one a to the 7th, or just a to the 7th, and then, so I can scratch that out. And then there's 5a to the 5ths. Oh, look at this, they're going to cancel out again, minus 5a to the 5ths. So those have canceled, they made 0, 5 minus 5 was 0. And then the a's, I have negative 2 of them, plus there's 1 here. Negative 2 a's plus 1a makes negative 1 a's. All right, so altogether, the final answer is 1a to the 7th, no a to the 5th, I don't need to write 0, minus 1a. Or if I don't want to write those ones, just a to the 7th minus a. And incidentally, the way to type this in would be a caret 7 minus a. All right, next question. So let's see, t to the 6th, t to the 4th, and t. 3 t to the 6's, negative 6 4 t to the 4ths. Well, I forgot my t squared, though. I just didn't notice that one there, and t. So there's 3 t to the 6's here, and nothing to add to it. 6 t to the 4ths. T squares, there's only minus 7 t squares, and the only thing I need to add together are the t's. Negative 7 of them here, and negative 6 of them here. Negative 7 and negative 6, and that takes care of everything. So that's negative 13t. And my grand final answer is 3t to the 6's minus 6t to the 4ths minus 7t to the seconds minus 13t's. The remaining of these questions I'd like for you to try to do on your own, and I'll come back. I probably won't come back. It seems like that's enough examples. So please try to do the remaining questions on your own, and I'll just put the correct answers so that you can check. So let's see. Positive. So in the 7ths, I have 6 minus 2, so 4p to the 7ths. If you would pause here, try it on your own, and then come back for the solution. So try these on your own, and then come back to check your answers. And then in the 6's, I've got 5 and 2 makes 7, p to the 6's, got the 7ths, got the 6's, and then 7 and 3 make 13, p to the thirds. Okay, pause here if you're catching up. And there's no minus in front of there, so I don't need to distribute. So p to the z to the 5th, I've got 4 and 1 make 5. Z to the 5ths. There's only this term here in the 4ths, plus 6z to the 4th. And then the z to the thirds, I can add together 5 and minus 2 to make 3. Z to the third. Okay. All right, and that's it. So please attempt your assignment number 19.